Hello, this is question for June 2022, paper 3 from OCR. The positive integers x, y, and z are the first, second, and third terms of an arithmetic progression with common difference -4. So I have x, y, and z, and it's a arithmetic sequence or progression. Also x 15 over y, so x 15 over y, and z are the first, second, and third terms of a geometric progression. So I'm multiplying by the same number. Yeah. So that y satisfies the equation y to the power 4 minus 16 y squared minus 225. So with both sets of information, we are going to try to see a connection just for the y. Yeah. So if we start with either, so the first one is telling us that, for example, y is x minus 4, or that z is y minus 4, or x minus 8. Yeah, so it's helping us to have some connection between them. If this is a geometric sequence, this one divided by this one is going to be the same that this one divided by this one, which is r. Yeah, so we can write that 15 over y divided by x is going to be the same that z divided by 15 over y. And this is going to help us, because then if we multiply, we have 15 over y squared is going to be xz. And if we eliminate x and z, we write them in terms of y, we are going to have an equation in y. So x is going to be y plus 4. So this is going to be y plus 4. And z is going to be y minus 4. So y minus 4, which means 15 over y squared is going to, we can square it already. I'm going to square it. So 15 squared is 225 divided by y squared is going to be, this is difference of two squares. So it's going to be y squared minus 4 squared. So y squared minus 16. And when I multiply everything by y squared, I have 225 is y to the power 4 minus 16 y squared, which is the equation that we were looking for. Yeah, this one, just reorganizing. Yeah, that's the first part of the question, which is this one. Then hence, so we are going to use this, determine the sum to infinity of the geometric progression. Remember, the sum to infinity is a formula that you have in the formula booklet. Sum to infinity is the first term divided by 1 minus r. So we will need to find r on the first term, and we have an equation to solve. So if we solve this equation, we are going to find y. And if we have y, we will be able to find x, which is the first term, and the quotient between them. Yeah, so it's simpler once we have y. So we are going to solve y to the power 4 minus 16y squared minus 225 equal to 0. If we factorize this expression, we have y squared minus 25 and y squared plus 9 equal to 0, which will mean y squared is 25, y squared is minus 9. This is not possible because something squared cannot be minus 9, and y is going to be 5. It could be minus 5. It could be minus 5. Let's see. Let's carry on with y. So if y is 5, positive 5, do they say they are positive? They are positive integers, so it's just going to be 5. If y is 5, the first term is x, so I need to find x. X is y plus 4. So x is y plus 4. So it's going to be 4 plus 5, which is 9. So that's the first term, and this is a, yeah? That's the first term. And then the common ratio is the difference between these two or these two. We have y and we have x, so r is going to be this one divided by this one. So r is going to be the second term divided by the first term. Second term is 15 over 5 divided by x, which is 9. So I have 15 over 5 is 3. 3 divided by 9, which is 1/3. So that's my common ratio, which means my sum to infinity is the first term, we say is 9. Sorry, looks like minus 9. So 9 divided by 1 minus the common ratio. So this is 9 divided by 2/3, which is 27/2. Yeah? Or if you want, you can write 13.5, but I will leave 27/2. Yeah? And that's all with this question.